Hello students, welcome to our teacher app. I'm your physics teacher. Today we are going to deal about our Untitled Chapter, CLASS-9-LAWS. Okay students, let us start our introduction part of the lesson. Laws of motion. This lesson deals about the rules which are governing motion. Okay. So as an introduction part, we will deal about what is the natural state of a body. What is a natural state of a body? Clear? And the next we will deal about the answers, like what does Aristotle says about natural state of a body. And in the next part we had the topic known as Galileo inclined plane experiments. So these experiments or this set of experiments done by Galileo, and he found that here Aristotle said that rest is the natural state of the body. But here Galileo concluded that by doing this experiment, he concluded that uniform motion is also one of the natural states of the body. And Newton says uniform circular motion. Then Newton concluded that uniform circular motion is also one of the natural states of the body. So this is the one part of introduction. And the next one, Newton continued his experiments and states about his three laws, famous three laws. Those are known as Newton's laws of motion. Newton's laws of motion. Okay. So what are these laws of motion? He proposes three statements or three laws. First law, Newton's first law. Newton's first law. So this law states about the topic of inertia. Inertia is nothing but the inability of a body. Inability of a body to change its state of motion. Later, in this topic itself, we will deal about the types of inertias. Types: inertia of rest, inertia of rest, inertia of motion, and inertia of direction. So this is the first law. And in the second law, Newton's second law, first law actually deals about what happens to a body whenever the net force is acting on the body is zero. Net force means it's a combination of all the kinds of forces which are acting on the same particular same body, right? So that is known as net force. And here the net force acting on the body will be exactly equal to zero. Okay. But here in the second law, we will deal about what happens if the net force acting on the body is non-zero value. So it deals about that one. So to know or to apply this concept of net force which is not acting as zero, that means net force acting on the body is zero, we have to deal about subtopic known as momentum. Momentum is nothing but the quantity of matter which is in motion. We will deal about. Momentum is represented by the symbol P. Okay. So we have seen that momentum is nothing but equal to mass into velocity. We will deal about what is momentum. Later we will deal about Newton's third law. Newton's third law of motion. It's very simple. For every action there is equal and opposite reaction. So such that if two bodies are colliding with each other, they will exert equal amount of forces. For suppose this is the first body and second body. This force which is acting on second body will be called as F21. And the force which is acting on first body is called F12. These two forces are exactly equal and opposite to each other. So F12 could be written as minus F21. Okay. So this is about Newton's third law. And the next one we will deal about concept of application of Newton's third law known as law of conservation. Law of conservation of linear momentum. Law of conservation of linear momentum. So to apply this topic, there are certain conditions. For suppose two bodies are there. Let us suppose there are two bodies. First one is having mass of m1. Second one is having mass of m2. First body is moving with the speed of u1 and second body is moving with the speed of u2. Both are moving the same direction. The necessary condition for collision is momentum of first body should be greater than momentum of second body. Okay. If not, this condition is satisfied, collision will not be occur, and this is known as before collision, right? And whenever the two bodies are colliding with each other, this is called during collision. And during collision, the two bodies will exchange momentum. So this is acting force to one. This is the force acting on first body because of second body. Later, if the two bodies are moving in the same direction, they will attain velocities v1 and v2 having a mass of m1 and m2. Hence, they exchange momentum. Because of exchange of momentum, they having different velocities, even though they maintain same speeds. So finally, we will conclude with the formula here: m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Okay. And the last topic, as the last topic of the concept or the lesson, we will deal about the concept of impulse. What is meant by impulse? A simple topic as well as important topic. Impulse is known as whenever a large force is acting on a body for a short interval of time, the product of force and time is nothing but change in momentum is called as impulse. And the formula is given as I is equal to F into delta T is equal to delta P. Delta means, see here, delta means final value minus initial value. So this is the formula of impulse. This is change in momentum. Delta T means it is saying that the time is very small, and F is known as impulsive force. So these are the important topics of our lesson.